A sample of antimony is analysed in a time-of-flight mass spectrometer and is found to contain two isotopes, the 121 antimony and the 123. After electron impact ionisation, all of the ions are accelerated to the same kinetic energy and then travel through a flight tube that is 1.05 metres long. A 121 antimony 1 plus ion takes 5.93 times 10 to the minus 4 seconds to travel through the flight tube. And it's given us the formula for kinetic energy. It's asked us to calculate the mass in kilograms of one antimony 121 ion, and then to calculate the time for the 123 ion to travel through the flight tube. So remembering that 121, this is the mass of 1 mole in grams. So 121 into kilograms would be divided by 1,000 or times 10 to the minus 3. And then if we divide by Avogadro's number, how many are in a mole, we'll find out the mass of one ion. And if we do that on our calculator, we get 2.009 times 10 to the minus 25 kilograms. Let's write that on our answer line. Then it says calculate the time for the 123 ion to travel through the same flight tube. Now there are two ways to do this. You could work the calculation through using the 121 ion and find the you've got the distance, you've got the time, so you can get the velocity, you've got the mass, you could find the kinetic energy. And because the kinetic energy is the same for both ions, you could work your way back with the same distance to find the new time. But if you use that idea that the kinetic energy is the same, what we can see is that the half times mass of the 121 times by the distance over the time of the 121 squared, because this is what velocity is, would equal the half times the mass of the 123 times the distance divided by the time of the 123 squared. So you can get rid of some things here because the halves will cancel and the d squareds will cancel. So you can say that the mass of the 121 divided by the time of the 121 squared is equal to the mass of the 123 divided by the time of the 123 squared. And because the conversion factor for mass from grams of a mole to kilograms for one ion would be the same for both, we can actually just put in 121 as the mass, and then the time for the 121 was 5.93 times 10 to the minus 4, and we can square that number, and we can say that that is 123 divided by time of the 123 squared. So if we rearrange that, we can find that the time of the 123 is 123 divided by 121 times by 5.93 times 10 to the minus 4. This is just a rearrangement, and then square root the whole thing, and this will give us the answer. And if we put that into our calculator, and we should be hoping to see a number that is close to 5.93 because the masses are similar, so the time should be similar. So we put all that in our calculator, and what we get is 5.98 times 10 to the minus 4, and that seems like it could be a reasonable answer.